Everyone. Ow! Dude, you shocked me.
Hey, we're talking about static electricity.
Oh, all right, right on. Well, here we are, static electricity, 6th grade science, Kirkwood School District. Let's get to the goal. What's our goal today?
Well, we're looking at students be able to describe interactions of like and unlike charges.
Okay, so the static piece would probably be the charges. Electricity, remember we're talking about electricity, so it's the electrons. We'll be talking a lot about negative charges today.
Well, you know, like we talked about in the last video, we talked about the charged part of the atoms. And basically charge, we're not talking about like just a positive charge. We're talking about all the charges. Protons have positive charge. The electrons, negative charge. And the nucleus has an overall positive charge because of the fact the neutron really doesn't have a charge.
Right on. So when we're thinking about magnets, let's go all the way back to elementary school. And when we practice with magnets, when we tried to put two magnets together that were positive, both of them were positive, both of them were the north side of the magnet, they used this property, we learned about this property called repulsion or repelling. So two positives coming together would repel one another, okay? And there's a rule, okay, is that like repels like, okay? And opposites, of course, then, well, we'll find about that right about here.
Well, opposites of this, if they're the same charges, they repel each other. Charges that are different attract each other. So if you think about them, repulsion or positive and negative charges, if they're both the same, then they're going to push away from each other. If they're opposites, they're going to attract to each other. That's where the saying comes, opposites attract.
That's a song by Paula Abdul. They
Wow.
don't know who Paula Abdul is, do they?
Neither do I, Mr. McGee.
Oh, geez. All right, so this is a lot like magnets because like charges repel and unlike charges attract. So just like a magnet you see over there on the right side or the left side, depending upon what side you're looking at, you can see how those magnets seem as though they're floating on air. Well, they're not actually floating on air. They're actually using the property of the magnetic field to repel one another.
It's like air supply?
Would you stop with
Okay.
the 80s band references?
All right.
All right. And then the balloons over here on the left, they have a negative charge, as you can see with the little minus signs on top of them.
So can we see minus charges?
You can't see them, but you can feel them. A lot of times you can feel that sort of static electricity.
Right, okay, at-home experiment. Okay, pause this video.
Got it.
If it's wintertime or if it's cool out, go and roll around on your bed.
Okay.
And then turn off all the lights, make it dark in your room, and lift the sheets up. And you'll see a little mini lightning storm.
Oh, right
Those
on.
are the negative charges, moving
cool.
from one thing to another. Okay.
So this is different than magnets, though, because magnetic poles can't exist alone. Anytime you have a north, you always have a south.
Always.
But charges are different. Charges can exist by itself. I can just have a negative charge on something, and that's okay. I don't have to have a balance with that with a positive charge, and that's fine.
Yeah, that's what keeps everything together. So electric force, what we're talking about is that attraction or repulsion, or attracting and repelling between those charges. And you can see in the picture here, we've got those drawn in with like gray lines. Basically, that's just showing those, basically the fields, what they call them, that force that you can't really see, but you can feel when you're pushing two magnets towards each other and they want to push away.
Okay. So when we have a negative charged particle and you put it somewhere next to a positively charged particle, what you end up getting is you get unlike charges that attract. And we talked a little bit about opposites attract. And you can actually do this lab in this experiment. It's actually really cool. And there's lots of different ways that you can charge things, but Mr. Manwaring talked about the fact that you can just simply rub things together, okay? Whether it be fur, silk, no matter what it is, if you rub it together, you're going to get a charge built up on an object.
Absolutely. And remember, the only part that can move is the negative charge.
Which is the electron.
That's right.
That's right. So static electricity rocks, although you got to be safe with it. You can't exactly just walk up to your friend and shock them for no apparent reason. All right? You've got to be nice.
Or they won't be your friend for very long.
That's true. That's true. Yes. So here's an example of a picture where you've got one of the balloons is charged up and it's attracted to the wall, which has no charge. Okay, a negative and neutral, those things are opposites, so they attract one another. And you've got this other balloon kind of floating off into space here, where you can see that one of the balloons seems to be floating away because it's repelled. It has the same charge as that.
So next time you have a balloon, you go to a birthday party or you come home from a birthday party, bring a balloon, rub it on your shirt, and you can actually stick that balloon on the ceiling, wall. Many times I was taunted.
Does it look like that?
It looks just like the smiley face.
I love that.
My brothers used to do that. They rubbed my balloon and put it on the wall so high I couldn't reach it. It was so sad.
People do that to me now. I'm not very tall. Anyway,
wasn't going
this is what your dog could look like if you decide to charge up your dog.
Do not do this to your dog.
Poor dog.
No.
All right. There's a great animation, and I wish it would work. Or no. Oh, no animation working. All right. So what does it mean to be neutral? It means that there's no overall charge. All the pluses equal all your minuses.
That's
so you're
right.
balanced.
So you have an overall net charge of 0.
Right. So whenever something is charged, what's happening is they are gaining or losing electrons. All right. And this is an extremely difficult concept for 6th graders. When you gain an electron, since electrons are negative, you get a negative charge. So if Mr. Mannering were to shock me or discharge, all right, he is giving me electrons. Therefore, now I have a negative charge. I am getting that negative charge. If he builds that up and discharges it off of him onto me.
And the discharge feels like a shock. So whenever you feel those shocks, that's what's happening, is you're gaining or giving away some electrons that you have built up on you.
Got it. You can use these wonderful things like static electricity, static guard. You can use fabric softener that are all things that sort of neutralize that buildup of charges. So
think about next time you do laundry and you do laundry. The next time your parents do laundry or you help, you should be helping by the time you're in 6th grade. But you put in a dryer sheet. If you don't put a dryer sheet in, pull out the laundry, you'll see definitely some static electricity going on.
Right, and all those clothes are rubbing up against one another, and that's one of the main things. Static electricity does not flow, okay? Static means not moving. So, for example, we could not power up an electronic device that way. We would have to actually have the charges flow just for that specific instant.
And static electricity is so many charges moving that you wouldn't really want to power anything with them because there are so many. In order to get a shock, a discharge, it's usually very many if you're actually going to feel it. So,
okay. Let's talk about a balloon. I want you to look at this little animation here. It's pretty cool. Balloons and static electricity. So here you go. Check this out. We've got a balloon. We've got a sweater. Not a very attractive sweater.
I have one just like that at home.
Awkward. All right. So if we grab the balloon and we rub our shirt, notice what's happening.
Cool.
Isn't that cool? So notice what's happening. The
no
balloon,
pluses are moving.
Right. Not the positives, but all the negatives there. Now, if I bring that over to the wall.
Hold on one second before you do that, Mr.
Okay.
McGee. What if you left the sweater? Is it positive now, the overall charge of the
sweater? Well,
sweater?
yeah. The sweater has a positive charge because I've removed many of the negative charge, the electrons, off of those atoms, okay? So they're there. So then now I can take this, and now the wall over here in yellow, the wall over here as neutral, okay? It doesn't have a charge.
Yeah.
But when I bring this over, notice what happens. Like charges will repel, and notice all these negatives move away, and we have this positive-negative interaction, all right, which is pretty cool. Now, if I reset this, I bring the balloon close to the wall now. What if I rub it on the wall? Well, the wall doesn't really, it's an insulator, doesn't really have a whole lot of things moving around. So we move all those off of there, bring it over here. Now, watch this. Watch this. This is pretty amazing. 2 balloons.
Oh, 2 balloons are fun.
Yeah. So if I rub a second, well, I got a little charge there, but now you can see, you know, this balloon and this balloon, they don't want to be near each other very well. Look, I can move it around all over the place because they have like charges, and like charges, as we know, repel. Now, what's really interesting is if the sweater is positive and the balloon is negative, if I just sort of let go of the balloon, look what the balloon does. Why would it do that?
Well, because the overall charge is that they're both negative, so they're going to, right?
Yeah, well, and also the sweater is positively charged. So if I let go of the balloon, the sweater wants to make that like a magnet, bring it on in.
It's looking for electrons. So try the overall charge differences. Let's see, does that show what we got?
There we go.
Shows not much of what I wanted to show you. Anyways, never mind. Okay.
Oh, balloon! There it is. Okay. All right. So when we're looking at that whole design, we're adding electrons by rubbing. Okay. The balloon becomes charged because of friction, and that's a science word for rubbing things together. It adds or removes electrons. That hair is attracted to the balloon. You can see in this picture, the hair is attracted to the balloon because the balloon has a negative charge, and the hair doesn't have a charge at all.
Or a positive charge.
Right, or as a positive charge. Very good. All right, so in taking a look at this, our goal was that students want to be able to describe the interactions of like and unlike charges. What did we learn in this video?
Okay, so what we learned is that if we have 2 objects and we put them close together and they actually come together, that those objects are opposite overall charges.
Unlike, if you will.
Unlike, right.
Yeah.
Or one's positive and the other's negative. It doesn't matter which one, but we just know that moving together tells you that they are opposites. Opposites attract. Now, if you have 2 objects, like the balloons, and you bring them together and they push away from one another, then you know that they actually have the same overall charge and that they're pushing away from each other because of the overall charge. Do we know which one's positive? Do we know which one's negative? No. We can't see those charges. Does that really matter? No. We just can describe the interactions. That's the whole point of this goal.
Cool. All right, we'll see you next time.
See ya.